My name is Roger Mays. I am the owner of aMAESing Tool Manufacturing Company, Incorporated, and the inventor of aMAESing pipe fitting tools. I'm going to demonstrate my latest invention, the toolbox table. The table is portable with leveler jacks and incorporates the use of my previous pipe fitting tools. The purpose of the aMAESing mobile table toolbox is to provide a level, perfect work surface. The box lid is manufactured using a 1/4-inch plate. Included in the table are pipe vices, a new portable bandsaw attachment to line up the saw to ensure the cuts are square, a motorized spinner positioner with counterweight capabilities, a modified 1/2-inch tubing bender, all uniquely mounted on vices securely. The vices will also hold pipes in straight alignment and at perfect 90 degrees to each other for tacking or welding. The aMAESing table is easily stabilized and anchored with the leveler jacks that allow the table to be adjusted to level even if the ground is uneven or rough. The 3 precision machined pipes are located on 3 sides of the aMAESing table. Lengthwise, 2 pipes are parallel to one another. The 3rd pipe on the end of the table is exactly 90 degrees to the other 2 pipes. These pipes provide an anchoring spot for the portable pipe vices to hold and securely level and align and clamp down work pieces for fabricating. Storing all the tools inside the aMAESing table toolbox allows for easy transportation from site to site. This video demonstration starts by leveling the table lengthwise and endwise, opening the box and retrieving a hold-down dog and putting it in one of the holes on the box. The multiple electrical socket attachment installed. The table is leveled using the leveling jacks. The pipes that are opposite each other have been previously adjusted parallel, perfect, and 90 degrees level and square with the end pipe. The vices attached to the pipe act as a leveling alignment base to level, square, and secure the pipe to be tacked or welded. They are automatically level one way with the run of the pipe when clamped, but must be leveled to the run of the pipe on the table end. In between visual action, I will speak of some of the particulars not being shown in action. The pipes previously mentioned can be loosened and slid close to the box to facilitate entry into close quarters. All these tools can be mounted on handrails, stanchions, or vertical pipes in a confined work area. With the vices mounted, retrieving the hold-down dog and the overhead multiple socket attachment, we put it in place. There are many more applications that could be shown in this video. I have omitted them to keep this demonstration concise. We are developing a teaching video library to share in more detail further applications and innovation add-ons. We begin by mounting the vise that holds the spinner positioner and clamping the spinner to the vise. Then couple the electric AC/DC power module to the spinner. Next, on the opposite end of the same pipe, we mount the pipe vise under the pipe to hold the machinist vise on the vertical and the bench grinder in the bottom mounted below. This is a typical pipe vise mounting on base pipes, ensuring that it is level with the end pipe. The pipe vise for the bandsaw mounts on the pipe at the right-hand corner of the table when facing the lid opening. Hang the bandsaw table module on the vertical side of this pipe vise and clamp it tight. It is designed to level and square with the other vices in line with it when it is tightened up. With the saw table module securely mounted, we attach a handheld portable bandsaw to the arm coming off the table. It attaches to the factory threaded hole where the hand grip was previously located. The arm is designed with two adjustment mechanisms to ensure the blade cuts straight and square. With all the tools mounted in place, I will proceed with some of the applications and demonstrate their uses. The electrical cords from each tool can be plugged into the elevated junction box. This reduces the danger of multiple electrical cords lying on the ground. There are machined brass bushings on the inside of both ends of the spinner positioner. Starting with threading the 2-inch pipe fabrication into the spinner and pulling out the counterweight to compensate and balance the branch and flange weight for even rotating when welding. The spinner has 3 bushings in the wheel: 2-inch, inch and a half, and 1-inch. Note that the spinner positioner is mounted on the pipe vise that must be placed diagonally to the porter bandsaw to safely balance the tool weight on the table. Here I am adjusting pressure from the electric motor slip clutch to the spinner for safety. Place the foot speed rheostat in position for welding. The handrails that are level with the vices automatically level when clamped. With vertical stanchions and pipes being level and plumb in place, the work pieces will be level and ready to add on more pipe and fittings to complete an installation accurate and square. Clamping up 2 pipes with 90-degree fittings and leveling the 90-degree elbow with the run of the pipe. Now picturing is a 4-inch flange bolted on the spinner with a lateral pipe branch coming off the side, which necessitates extending the counterweight or adding more weight to the end of it to balance the piece. Under the saw table, there is an adjustable stop mechanism that provides for same length saw cuts. And showing the saw cut to be square in both 90-degree axes. Placing the modified machinist vise in the pipe vise on the bandsaw mounting to show how it can hold small pieces and make straight cuts. Showing the bending tool bending half-inch stainless steel tubing for instrumentation. Note that the shoe on the modified bender is automatically held level while the next bend is plumbed with a hand level to ensure the bends are 90 degrees to each other. We are clamping up a 90-degree joint with two previous 45-degree pipe cuts. The welding gap is ensured square and held square by pipe vise clamps for tacking or welding. Also note the butt weld lineup. Clamping up vertically a 2-inch pipe which is automatically plumb in both ways when clamped. Adding a 2-inch weld neck flange on one end. Looking through the flange to minimize high-low in the joint and using a gap blade for correct spacing, and checking with a pocket level to ensure that it is square in both axes before tacking. Now demonstrating the motorized rotating positioner for Healy arc welding. Using two hands necessitates the use of a foot feed rheostat speed control, keeping the molten welding puddle on top of the pipe to ensure optimal penetration and high-speed production. Using the adjustable counterweight balances the eccentric weight load. Please note the mechanics of the clutch between the electric motor module and the spinner wheel. A safety feature allows the clutch to slip when an obstruction, human or mechanical, inadvertently comes into the line of rotation. Note the movement of the counterweight coming up. This is showing the value of having a machinist vise mounted for holding small, irregular pieces for sawing straight cuts. Now demonstrating the use of the grinder. Putting the aMAESing tools back in the box and locking them up for safekeeping, showing the ease of moving the aMAESing toolbox from one workstation to another.